or talk about, yeah. Probably shouldn't be saying all those unkind things on this webinar. Okay, so anyway, guys, so again, I'm really hoping we can be a little more attentive than we were last Friday because there's no assembly.
When did we say yes?
All right, combustion or composition or synthesis is when you build something out of its elements. We saw that with the zinc sulfide kind of work. It worked really well during second period today. The thermite lit it on fire. Anyway. Hey, that's a reaction from Friday. And then decomposition is when you break something into its elements. And then hydrocarbon combustion is what you get when you have a fuel reacting with oxygen to produce carbon dioxide and water. And I think this is like where we try to get, and then the bell rang. Yeah.
That one blows up.
Most of them do. Yeah, most things do blow up. In fact, let's do a couple simple ones. My kingdom for more pens. So we're going to do a simple one, and I need you to balance these. Need you to be an active participant in your education. So this is methane, and methane when in the presence of oxygen will burn. Methane is the primary component of natural gas that comes out of the pipes and eats your water and air and stuff. Anyway, that's a gas, and that's going to produce what two things?
Methane oxide.
Water.
And?
Carbon dioxide.
Water and carbon dioxide. Good. So hydrocarbon combustion always makes water and carbon dioxide. So this is one of the easier ones to balance. So we can give it a try. Again, you can use your double technique where you have, if you have an odd and an even, you double them before you do any kind of balancing. That's usually a pretty good technique. This is so simple it's not even necessary, but go ahead and give it a try, and then we'll come back together here in a second. And if I say, I don't mean like do it in your head, I mean do it on paper. You know, use the paper that God gave you. And
Yeah, we cut down the trees.
yes, we cut down the trees and we grow new ones in their place. Well, that's the. So you guys don't realize it. You think saving paper saves the planet? It doesn't. Using paper saves the planet. Because if there's a desire, if there's a need to use paper, then people will plant trees. And the more trees we have, the more carbon dioxide we'll displace.
Reduce, reuse, recycle.
You want to go in the back? There's a big table in the back.
We're doing an experience.
Oh yeah.
Like a lights me on fire today?
If you're a woman, are you doing your work?
Yes, I am.
Okay. Show me how well you can do your work, and maybe you'll get to be the person who lights it on fire.
I got high balance.
I don't understand this.
So maybe we need a little refresher. So again, you don't always have to do this, but it's a good technique. That is, should you have compounds that have an odd and an even in the same compound, if you have an odd number of carbons and even number of hydrogens, it's generally a good idea to double all those things, because if you double all those things, they all become even, and that just makes things a little more convenient. Now let's look at this. How many carbons do we have here? 2. 2 times 1 is 2. And then how many carbons do we have here? 2. And how many hydrogens do we have here? 8. 2 times 4 is usually 8, so 8. And how many hydrogens do we have here? 4. Can we make this 8? How would we do that? Yeah. Get rid of the 2 and replace it with 4. Now we have 4 hydrogens, or 8 hydrogens. 4 times 2 is 8. 2 times 4 is 8. 8 hydrogens, 8 hydrogens. Now look at the oxygens. How many oxygens do we have right here? And how many here? For a grand total of 8 oxygens. How many oxygens do you get over here? 8. How do I make 8 oxygens on this side?
You add 4.
Put a 4 right there. So then we ask ourselves, do we balance it? Well, 2 carbons, 8 hydrogens, 8 hydrogens, 8 oxygens, 4 plus 4, 8 oxygens, and it's balanced. Now, this is technically balanced, but we can reduce, and we should reduce. So 2, 4, 4, 2 can be reduced down to what?
1, 2, 4, 2.
1, 2, 2, 1. So we can reduce it down to 1, 2, 2, 1. 1 carbon, 1 carbon, 4 hydrogens, 4 hydrogens, 4 oxygens, 2, 2 is 4 oxygens.
I went to Myers, that's very complicated.
It'll become very, very easy. Okay?
Can you just do that first, though?
Yeah, you can totally do that. You don't have to do the doubling method. It's just, it's a good technique to get into because it makes things easier in the long run. Because sometimes we'll have compounds that are like 4, 6, 3, 9, and you're like, cool. So doubling it makes it easier. Okay, so there you go. Do you want to see a combustion of methane?
Yes.
Yep.
Question.
So I guess Brett's volunteering ahead of time. He's got his goggles ready to go.
What is Brett?
Why does Brett get to be my favorite?
What do we want to do? I want to do some
All right. Let's see here. This is our fire pencil. Cool. Okay. Go ahead back down there by Grace. Grace, you probably want to move back a little bit. Hey, look, I can move the camera around. Isn't this fun? This is gonna be yours. And I'll put the camera right there. Okay. You're gonna be on the tubes. Okay. Stand right here. Chloe, can you turn the lights off, please? Okay, so let's practice using the fire pencil. Turn around, aim it like this. Now, here's the thing about the fire pencil. It's got a tiny amount of gas in here, and it makes a flame. Now go and wave it around. Okay, cool. Now if it goes out, it's very easy to go out. If it goes out, bring it to me, I'll relight it. Okay, now your goal, or your job is to light the bubbles on fire before they get to the roof, but not before I release them. So bring it over here. There you go. Okay. And here we go. Okay, you ready? Here comes your first bubble. Hey! Oh, we lost one. And there's a chance you'll light the gas after the bubble bursts. If the methane diffuses too quickly, you won't be able to light it. But if it doesn't, then you can light it. See, like that. You could have actually lit that. Hey, that's fun. Okay, you're right. Oh, you're definitely It's called a funnel. There you go. Oh, there you are. Right. That's happened. That has happened in the past. You ready? Here comes the big one. Oh, not good enough. Going out. Mr. Byers is on fire! There we go. Oh, look at that! Oh, yes. Okay, let's get 1 or 2 more good ones. Oh, it's a big one. Oh, okay. That was a good one. We'll give it one more try. Another big one. Oh, wow. Splendid work.
One more.
Oh, no, those were excellent. Brett did an excellent job.
I'm with Brett. Yeah, Brett.
Okay. Now we'll just bring this thing over here. All right, guys. Okay, so that was methane. Yes. So methane is, by the way, I talk about this, guys. When you hear the word meth, it doesn't mean drugs. Meth is just a prefix of a chemical type. So methane is the simplest kind of chemical that has a meth group on it. Methamphetamines. Okay, so this is methane. Methamphetamines is like.
And that's the drug?
Yeah, that's the drug. So methane is a small car. Methamphetamines is like a super tanker, oil tanker. Okay, so there's this crazy chemical, guys. There's this crazy chemical that a lot of girls will use to not interrupt me, please. Hi. Okay, so there's this crazy chemical that women will use to take the nail polish off of their hands. And it's really good for dissolving plastics. Acetone. And acetone has the formula C3H6O plus O2, and it does burn, and it produces CO2 plus H2O. Now this one's a little more complex to balance. Not hard, it's a little more complex. So again, I recommend you use the doubling technique because you have an odd, even, odd. So start by doubling everything that is odd, even, and then balance this if you wouldn't mind. Are you doing your work? Or are you expecting me to do all the work?
I would never expect you.
School is where kids go to watch adults work.
It's true.
Yeah,
our first
period.
Yes, I am. Do your work.
Super hot.
Yeah, I'll tell you about thermite once we get to the next reaction type.
You should light it off on top of my phone.
Okay.
Be sick.
Your parents are cool with that?
Probably not.
Yeah. Because that'll be the end of the phone. That'll be the end of the phone. Everything anywhere near it.
Yeah.
Okay, so the conversations are wandering away from chemistry. So does that mean you guys are done and ready to move on?
Talking about I would do
chemistry, in which I learned about
They sing about
chemicals. Yes, and the chemicals involved with chemistry.
What's the band called?
The band's called
I don't know how to
the Cheminos. The Cheminos is the band.
hold your
He's laughing.
Yeah, I'm like a clown. I'm smiling on the inside.
That's a good name. So why do you use subatomic?
Subatomic. That's a good one.
So you guys balancing this? This is not hard to balance, guys. You just have to realize that you have multiple places of oxygen. The good news is oxygen's all by itself right here, so you can adjust that number last.
You need 4 oxygens on one side. No, you need. I don't know how.
Okay, so let's go ahead and take a look.
Don't you need 8
Boom, got
oxygens on one side?
Boom, got it. Okay, so
Yeah,
my favorite student has got it, so let's move on. How many carbons do we have over here? How many carbons do we have here?
6.
3,
2 times 3 is usually 6. So this carbon needs to be how many?
6.
6. Let's just get rid of this 2 and
Make it
replace
6.
it with a 6. So far, so good?
Yeah.
Now, how many hydrogens do we have over here?
12.
Or 12.
12. 2 times 6 is usually 12. So how do I make this 12?
Multiply by 6.
Put a 6 there too. All right.
You put a 6.
Now we're banging with all cylinders. Now, how many oxygens do I have on this side?
2.
24.
I have 12 on this side and
6 on this side.
24.
6 on this side. Again, there's a 1 right here, right?
Wait, no.
So 6 times 2 is 12. 6 times 1 is 6.
Yeah.
There's 18 on this side. Now, right now, how many are on this side?
3.
4. Not enough. So, if there is 2 of all this, and this needs to be 18, then what does this need to be? Or what does that need to be?
8.
An 8. It needs to be an 8, because this is going to be 2 and 16. 2 plus 16 is usually equal to 12 plus 6. Okay. Even my 4-year-old can do that. No joke. Okay, so cool. We're done, right?
Yep. No.
Yeah. Let's reduce it. We have a 2, 8, 6, 6. What can that be reduced into?
1,
1, 4, 3, 3. And this is why I'm recording it. This is why I'm recording it. 1, 4, 3, 3. Now I want to show you something really cool. If you've never seen one of these, this is called a candle.
What?
And fun fact about candles, they're not what you think. Solid candle wax, does it burn?
No.
No.
It's the wick.
Liquid candle wax, does it burn?
No.
No. In fact, some of you who have candles, you have a little wire that pushes the wick into the liquid wax, and it goes out. So liquid wax doesn't burn, but gaseous wax does. So the liquid wax goes up the wick, heats up, and evaporates. And it is the vaporous wax that actually evaporates. Now this is acetone.
And there's all the chemicals in it?
Very, very few things, very few liquids and very few liquids and solids will actually burn. Acetone, like most things, its liquid won't burn, but its vapor will. So I'm basically filling this flask full of vapor, and watch what happens.
Oh.
Wait, do that again.
That's very cool, Mr. Runner.
Can you see vapor?
Yeah.
When it's on fire.
You can't see the vapor,
Pour down.
but so you can see the liquid acetone in here, and then the vapor is actually heavier than air. You can't see the vapor, but it is the vapor that does the burning.
What if you pour the actual
Whoa.
It'll make a big mess.
Oh,
Yes.
well, make a fire.
Why does it go up?
Because the vapor is basically, like, imagine a cloud of vapor, so that this lights and this lights, it lights the entire cloud.
It takes that long to get all the way out.
Here, I'm going to put a little bit of liquid on there here in a second. Oh, look at that, put the candle out. There we go. And anyway, what happens with the liquid down there? Well, this. Yeah.
Whoa.
Whoa, that's a lot of burning. Okay,
Oh,
so there you go. All right, so that's hydrocarbon combustion. Some sort of film, some sort of fuel, plus oxygen makes carbon dioxide and water. Now the next type of reaction, you're probably going to burn for a while. The next type of reaction is what happens to you at the dance. So you know what happened when you were in the homecoming dance, and you were dancing with your date, and then a big football player came in and said, "I'm cutting in," and then she was dancing with your date.
That's the story of my life. 18 guys, come on. 5 or 8.
So that's what happens in a single replacement reaction. In a single replacement reaction, one thing that is all alone kicks out something in a compound, and that thing that gets kicked out becomes all alone. So the one you guys want to see is thermite, right?
Yes.
Oh, yeah.
All right. So thermite's pretty simple. It's before there was gas welders, and well, now it's like electrical welders, plasma welders. But before there was plasma welders and gas welders, there was chemical welders. So you might realize that 150 years ago, they wanted to get people from the Atlantic to the Pacific. How'd they do it?
Steam engines.
Railroads, right?
I
Railroads.
was close.
So they had to have a way. They had to have a way to connect the metal rails. So there was one consistent rail that went from New York to San Francisco. And what they do is they would use thermite to melt the rails together. So aluminum powder, when it reacts with iron oxide, Fe2O3, which is a solid, it makes liquid, hot, molten iron, and then aluminum oxide.
Wow.
And this is something you can balance. So while I prepare the charge, you balance it.
I'm gonna balance it. It's pretty You're not wrong. Walmart? Where do we get it?
You can probably get it at an air gas or a welding supply store.
Could we buy it like?
Or you can make it yourself.
Could we buy it at like 17-year-old?
You just bought iron oxide and aluminum powder.
You can buy all that stuff on Amazon.
Yeah, you can buy iron oxide and aluminum powder and then you mix it together.
No, dude, you can make like a thermite board right
Do you have directions right this time?
Yeah, the tricky part is actually getting it started. It's exceptionally hard to get started. Mr. Cox and I had a lot of trouble getting him started for a long time with for reasons we don't understand. And then somebody realized that magnesium is really good at getting it started. So we use a magnesium sparkler. So this is my thermite, my magnesium sparkler in there. It's going to make a tremendous amount of heat, like a lot.
Will we be able to feel it in the front row?
You don't want to be in the front row. You're going to be like far away. But you will wear glasses because there's a lot of water out there, and the last thing I want is spitting hot rocks sliding in your general direction.
Great.
So
Glasses. 2AL.
Glasses are important.
2AL, FE, 2
2AL.
Yeah, and then 2FE plus AL.
Okay, let's see if my favorite student is right. 2 aluminums, 2 irons, 3 oxygens, and it looks good. Okay, so the rules are we are going outside, so you can grab some glasses and head outside to the usual reaction area. Hopefully my stuff is right there.
With these here? No.
Does somebody want to grab my camera?
Favorite student got it.
You know it.
Are you gonna light it on fire, Brett?
Okay, so
Maybe.
I have 6 eyes.
Yeah.
These ones look so funny.
There's 6 eyes.
Yeah, no, those black ones specifically. Because one was wide.
I'm not the only one looking. I feel so smart. Hi, Miss. Oh, those hurt my eyes.
I saw the video of you and Scotty standing there when you're pouring the water.
and it went boom, and that's why I'm doing the thermite first instead of the sodium.
Kinda
But
like
yes, in fact, let's do it over here in the dirt. Okay, you gotta move away, move away.
Try lighting.
Okay, guys. Yeah, you're probably a safe distance.
Probably
Everybody,
a safe distance.
this is really hard to get going. So everybody think warm thoughts. There we go.
Oh, I thought one thought. That's why.
Oh yeah.
It's a firework.
Right. So,
So bright.
what you're seeing right there, that really, really bright rock,
That's iron.
that's liquid iron. Yeah, that's liquefied iron.
Wait, can I have the
I could feel that. I can feel.
I like that noise. That's good.
It's a wholesome noise.
Yeah, that's a wholesome noise.
ASMR.
That's good. That's good stuff. Yeah.
I feel like I was looking in the sun.
It smells great too.
It's pretty bright. So you just made a raw.
I should have looked straight at it. Have it?
I like how the pill bottle is just
Pretty
gone.
hot, but let's see if we can pick it up with a magnet.
Yeah, the pill bottle is gone.
You can have that metal rock.
I want one.
Do you want the other metal rock?
I want one.
I'm gonna put it on the ground. I don't know if it's actually hot.
It's not hot, don't worry.
It's not hot? Okay. Good point. Yeah, very good point.
Like metal?
Like metal. Okay, so keep your glasses. We're gonna go inside and we're gonna do one more thing. And yeah.
Not very hard. Also, it smells disgusting.
So go back inside. We're gonna do one more reaction. We're gonna come back out here in a second.
I need to get more water.
It's definitely a good idea.
If you can close your eyes, you can still see it. Just burn into your retinas. I think ish. Good job, Brett. Very soon, you know it.
Make sure you get it. Oh, is that magnetic?
Right there, Mr. Byers.
Yeah, perfect.
Hey.
It looks like it
Okay.
needs to be made, like, adjusted. Like, it looks
It's got a fat wide lens.
Why does it smell like sulfur?
When it's right there, it'll see either end of the. Probably because there was a bunch of sulfur out there earlier. One of the zinc sulfide reactions didn't go. Okay, guys, So one more really popular single replacement reaction, I've been mentioning it before, is when sodium metal reacts with water. Now I've said it multiple times, sodium's a really goofy metal. It's soft, it's highly reactive, it will react violently with water. And when it does, it's going to make a compound of sodium hydroxide, and it's going to make hydrogen gas. That's going to be gaseous, that's going to be aqueous, that's going to be a liquid, that's going to be a solid. Now, if you look at this, guys, if you look at this and you're learning about balancing, you might automatically say, I don't know how is that, there's an O there, how does the OH go do that? This is why. Chemists don't see water as H2O. Chemists see water as HOH. Hydrogen hydroxide. Okay? Chemists see water as hydrogen hydroxide. Now if you realize, okay, that's hydrogen hydroxide, then you can see how the sodium, all by itself, is going to kick out the hydrogen. The sodium will then join with the hydroxide to make sodium hydroxide, and hydrogen is going to be what's left over. So, and we are going to need to balance it. So